Hi everyone, my name is Putri Anukansa binti Idris. Today I will present about my final year project entitled Optimum Chime Sound for Vehicle Driver Alert. First and foremost, let me introduce a little bit about my final year project. The automotive industry has become more prevalent due to emerging the growth of technology. Warnings are usually expressed when there is something wrong with the system that requires immediate attention. According to News and Walker in 2011, expanding innovation in vehicle safety technology and information has created new options to lessen traffic accidents and improve driver alert in the surrounding. In addition to sensor, the key parameter of chime technology consists of visual, audio, and haptic. Built-in software allows the vehicle to operate and stop or drive the car in certain conditions. This safety technology has been combined in the latest model of car. Shafiq Muhammad 2017 stated that vehicle safety features aim to assist drivers while driving by aiding them in avoiding error, warn driver of any imminent mistake as well as cater partial assistance during driving. A chime can be an audible indicator for various alerts. Figure 1 shows the example of chime-related technology that are available in vehicles. It is anticipated that this technology will start reducing the accident caused by risky and careless driving. However, the security feature or driver support feature do not replace driver responsibility for the safe operation of the vehicle. The driver must always be careful about traffic, the environment, and road conditions. There are two problem statements in the study. The first one is annoyance. There is a perennial concern for auditory display design. A survey reported that 70% of drivers turn off the warning alarm because they are irritated with the audio characteristic. And next is false alarm are mistakenly identified as an adjacent track. Too many sound can impregnate the surrounding and trigger dangerous event in system. Therefore, some characteristics must be studied and tabulated. Main goal of this study is to determine a effective warning sound for vehicle safety feature that could assist in driver reaction to possible danger and work in harmony with other sound in the vehicle. There are three objectives in this study. The first one is to develop a database of vehicle chime technology to conduct analysis based on the collected sound from OEM or vehicle manufacturer and to recommend optimal sound characteristics for effective driver reaction to driving environment. Next, we move on to literature review. About a decade ago, behind chime in car there was a mild sign. Some car manufacturers had a dedicated sound speaker and others even used raw noise from the electric transmitter to transform signal and other warning. However, with advanced vehicle safety technology features introduced to car and vehicle, the number of sound has increased and their function has been diverse. Based on the graph on Figure 2, we can see that the recommended optimal sound frequency and power for vehicle chime technology is equivalent was in the range of 70 to 90 decibel and between 100 Hz and 5000 Hz. Gamba et al. Concluded that auditory warning were appropriate while a high priority warning is needed. In example, imminent collision warning, driver may be distracted and attention need to be drawn directly to the location of potential crash track. The study consists of three methodology phases, namely development of chime technology database, survey development on awareness and perception, and optimal sound characteristics. For the phase 1, the database development process starts by exploring available audible vehicle alert technology in the market of vehicle safety technology. Then we develop chime technology database using Microsoft Excel to be distributed to OEM and vehicle manufacturer. After that, we review the auditory alert characteristics for in-vehicle safety technology. In order to survey development on awareness and perception among Malaysian drivers, we conducted a data collection that need a minimum of 120 respondents that categorized into 4 age groups. And the questionnaire has been divided into 4 parts, which is part A, asking about demographic data, the background information about the respondent. Part B focus on the driver awareness on in-vehicle safety technology with auditory alert, and Part C focus on driver perception, and for Part D for audio test. Figure 3 and Figure 4 show the layout for data collection that been used during the process. For Phase 3, after we collected the survey result, we analyzed it using Minitab software version 20 and we mapped the survey result with Chime technology database according to three main alert characteristics, which is sound frequency, sound pressure level, and urgency. So we go to result and discussion. Considering the result in Table 1 Chime Technology Database, we can distinguish the optimal sound level based on their frequency. As we can see that the red highlighted box exceeded the normal sound frequency. Thus, when the sound was too high or loud, driver will quickly turn off the alert. As can be seen in Table 1, the Chime Technology Database consists of five different vehicle brands that we label as from OEM 1 until OEM 5. Data collection for a survey on driver perception on awareness is conducted in Klang Valley, where a total of 150 respondents participated. The majority of respondents were Malaysian drivers from 80 to 90 years old. Majority and 72% of them own a car. Figure 7 illustrates the proportion of buying factors considered by the respondent. The top 5 that are considered necessary by respondent when purchasing a vehicle are comfort at 74.0%, followed by cost at 69.3%, and fuel consumption at 64.7%, engine performance at 64%, and safety technology feature at 57.3%. Based on the survey result in Figure A, the top vehicle safety technology that's selected by Malaysian drivers are pre-collision warning, blind spot monitoring, rear cross traffic alert, draw a child left open warning system, and collision mitigation braking system. These vehicle safety technology are classified as very important safety technology. Approximately more than 90% of respondents agree that vehicle safety technology with audio alert are helpful in avoiding crashes and during emergency situations. Therefore, based on the audio test conducted in Part D of the survey, the respondent has selected their preference to perceive agency based on audio alert with sound pressure level at 65 dB and frequency varies at 500 Hz, 1000 Hz, and 1500 Hz. Based on our finding, 80.7% of respondents were comfortable with the frequency of 1500 Hz and found it urgent. However, they regarded the audio as most annoying. For the frequency of 1000 Hz, 78% considered the audio was comfortable, urgent, but slightly annoying. Meanwhile, 75.3% of respondents considered audio with the frequency of 500 Hz is comfortable, but they regard the audio as neither annoying nor urgent. Hence, the frequency of 1000 Hz is the respondent preferred frequency for the auditory alert. These are photos from the data collection that we conducted. In conclusion, this project has succeeded one of its objectives, which is to develop Chime technology database. Hence, the comparison between Malaysian driver preferred frequency and OEM frequency was also studied. Most of the vehicle safety technology provided by OEM are within the recommended frequency range. However, certain technology exceed the maximum recommended frequency by ISO 50006 in 2011. Moreover, the analysis based on the collected data is successfully achieved since Malaysian driver nowadays has higher awareness toward purchasing vehicle equipped with advanced vehicle safety feature, better engine performance, and value of money. The Malaysian driver also aware that the technology are very helpful to avoid crashes and during emergency. However, they find that technology distracts their driving focus. And lastly, in this study, the characteristic of auditory alert in ensuring vehicle occupant safety has been revealed. Furthermore, based on the finding, the recommended optimum chime sound was successfully identified, which is 1000 Hz at certified decibel. The automaker could benefit from this recommended frequency by providing the frequency of auditory alert following the Asian NCAT guideline for safer car in the country. It is hoped that in the future, this study will help policymakers, manufacturers, and other stakeholders spread awareness about vehicle and driver safety in the country. With that, ladies and gentlemen, thank you for your attention.